The seventh objective of Practice A, we are being asked to calculate enthalpy changes using standard heats of formation. The standard heats of formation is a test-taking tool page. It comes from the Appendix C of our textbook. Objective 7 needs the standard heats of formation chart so we can look up the constants for each of the reactants and products. We will need to have out the tool page given to us in class. If I'm being asked to calculate the standard heat of formation of a specific reaction, delta HF, I know that it will be found by taking the standard heats of formation of all of the products added together and subtracting the delta H of formation of the reactants. Products minus reactants will give us the overall equations value for delta HF. In our first question, it reads, using the values from our standard table of heats of formation, let's calculate the delta H for each of the following reactions. The first one, letter A, has us finding N2O4 as a gas plus 4 units of H2 as a gas, forming N2 gas and 4 units of H2O gas. We'd like to know the delta H of formation for this reaction. Products minus reactants. Let's begin by using our Appendix C, the thermodynamic values of each of these reactants and products. And I'll just simply look them up and record them one at a time as a tabulation under each ingredient. For instance, N2O4 as a gas. Remembering the Appendix C, the thermodynamic values, are listed in alphabetical order. I want to find the N's, so I'll flip to the back side and start searching down N2O4 gas. I'm finding N2O4 on the back column, about a little more than halfway down. N2O4 in a gas is positive 9.66. Let's record that right underneath it. The second is hydrogen gas, H2. Now, elemental form of hydrogen does belong to the Lucky 7 Club. It is written in its natural state. Search down until you find H2 gas. It's on the front page, skimming over, has a value of 0. We'll record that right underneath it. N2 as a gas. Again, alphabetical. Let's go to the N's. Finding N2 gas also reads a value of 0. No heat of formation required to build an element in its natural state. The next product is water in the gaseous form. Now water, for whatever reason, has been listed under the oxygen. On the back form, skim down to find gaseous water. There's both values, gas and a liquid. Water as a gas, negative 241.82. Let's record that. Negative 241.82. Now, every coefficient needs to be distributed through the values we just found. For instance, the first reactant, N2O4, its coefficient is a 1. We'll distribute a 1, it will remain the same. 4 times 0 remains 0, 1 times 0 remains 0, but the water will be 4 times the value of negative 241.82. Plugging into our formula, the delta H for this reaction will be found by taking the product minus reactants. Products minus reactants. The products is 4 times negative 241.82 negative 241.82 plus 0. The nitrogen's value is 0. Now I don't need to write that, but I will to emphasize that I'm including both the water and the nitrogen. We will subtract that from the value of the reactants. 9.66 plus 0, the value of our reactants. Products minus reactants. Let's hit and see what we find. 4 times negative 241.82 equals negative 967.28 minus the value of 9.66 and I'm finding negative 976.94 kJs. Products minus reactants give me an exothermic value, negative 976.94. Our second part of the first equation, 2 units of KOH solid plus 1 unit of CO2 gas produces K2CO3 solid plus 1 unit of gaseous water. Products minus reactants, we need to look up the standard value for each of these one at a time, and I'll just keep tabs by writing its value underneath each of the ingredients. First one listed is KOH in a solid form. I go to my standard charts and I start looking for the value of KOH as a solid. On the back side, KOH is listed twice, one's solid, one's aqueous. Be sure to grab the solid, negative 424.7. Next one listed is gaseous carbon dioxide. On the front side for the carbons, gaseous carbon dioxide, here it is, negative 393.5. Let's record that, negative 393.5. Next one listed, potassium carbonate. Again, would be found in the Ks. K2CO3 in a solid form. Middle column, negative 1150.18. Hard to read. Negative 1150.18. And 1 more unit of gaseous water. Gaseous water we looked up just a moment ago, so I think I'll just grab it from the previous problem. Negative 241.82. Products minus reactants. Remember to distribute through any coefficients. Now the first reactant had a coefficient of 2. We'll need to distribute that, making it twice as large. The other coefficients are all 1s. We're good there. Products minus reactants would begin by saying negative 1150.18 plus negative 241.82, the sum of the products minus the sum of the reactants. 2 times negative 427.7 plus negative 393.5. Products minus reactants. Let's begin hitting, simplifying as we need to. In the first parentheses, negative 1150.18 plus a negative 241.82. So far, my first parenthesis is equaling negative 1392, simplifying the first parenthesis. Let's do the same in the second parenthesis. 2 times negative 427.7 equals plus a negative 393.5 equals The second parenthesis is simplifying to negative 1248.9. We have the simplified first parenthesis and the simplified second parenthesis. We need to do a subtraction, products minus reactants. Taking the value, we simplified for the first, negative 1392 minus negative 1248.9 equals, I get a value of negative 143.1 kilojoules, an exothermic value. Products minus reactants. Using the standard heats of formation, simply looking up each reactant and product, remembering to distribute through any coefficients before we begin the math.